In this lab, we will continue from the previous lab. In the previous lab, we looked at the pattern of the decomposition of the data, the passengers' data, into the observed the passengers' data into trend, seasonal, and residual. So we used two models. We used HTL decomposition method, and we used seasonal underscore decompose method. Model was for additive, and if the residue pattern, if there was a pattern in the residue, then we would have used model multiplicative. In this lab, what we will do, we will drop the COVID years from the analysis and we will see what happens. So we'll split the data into pre-COVID. So let pre-COVID equal, so we had, let me show you decompose. So decompose. So we have decomposed data over here, and the month year is going up to 1st of February 2020. So now, the year is going up to 1st of July 2022. So this is the decomposed data containing all the passengers data in thousands. Now from here we will subset the row 176 and up to 176. So from the first row we will make a copy of until the row number 176. So let pre-COVID equal decompose square bracket colon 176 dot copy open and close bracket, and printing pre-COVID, we get this. So it goes up to 1st of February 2020. Now we split the data into post-COVID. Let post-COVID equal decompose, and that is from the rows 176 and onwards. So square bracket 176 colon dot copy open and close bracket. So we get this. So it's from the date 1st of March 2020 to 1st of July 2022. And then we rerun the HTL decomposition code. Let outcome equal HTL of pre-COVID but of passengers thousands column. So HTL of thousands column dot fit open and close bracket plt.rc prompts dot update bracket dictionary. This contains all the parameters. Figure dot fix size colon width equal 10, height equal 10. Outcome dot plot open and close bracket dot subtitle of STL comma x equals 0.15 comma y equals 0.95 comma font size equal 14 comma color equal red. So we can see that puts HTL in the position 0.15, 0.95. plt.show open and close bracket that shows the observed values. and this is up to 1st of February 2020. Then we see the trend is a linear trend, then the seasonal, which is a pattern, it's a yearly pattern, cyclic pattern, and then we see the residual, and the residual shows a pattern around it's all around zero line. It doesn't show a pattern, it's all lying around zero line, so additive decomposition is good enough. Rerun the additive decomposition code. Let result add equal seasonal underscore decompose of passengers in thousands column, seasonal underscore decompose of passengers in thousands column, comma model equal additive, comma extrapolate underscore trend equal frac. So the trend is the frequency, so model is additive. Let's see, plt.rc prompts dot update of dictionary K is shown by Kelly braces, and that's the list of parameters. Figure dot fig size colon width equal 10, height equal 10. Result add dot plot open and close bracket dot subtitle of seasonal decompose, comma x equal 0.2, y equals 0.95, comma font size equal 14, comma color equal red. Plt dot show open and close bracket, and we see the actual values which are linear. The trend is a line which is going upwards in a positive direction, and the seasonal is showing a cyclic pattern for every year, and the residue is around 0. Our result add object contains data frames. We can check that observed equal trend plus seasonal plus residual. Let's check that. When we print the HTL the outcome, then print outcome dot observed looks like this. And print outcome dot trend looks like this, and there is seasonal and there is residue. So let's look at the concatenation of all these values. So the concatenation will put this in a table form, and with all the values. So let reconstructed equal pandas dot concat of square bracket resulted dot seasonal, comma trend, comma resid for residue, comma observed, close the bracket, square bracket, comma x is equal 1. So printing the first 10 lines, we get this. So this can also done by putting a double square bracket. So let me show that to you. So instead of pandas concatenation, we will put another bracket here, square bracket. So we will enclose all these values, the outcome values, using another square bracket. So let's look at the first 10 lines of it. So oh yes, so result 8 should be outside, and then inside all the outcome. Uh, so no, so that doesn't work. So we will just keep those values. Okay, so let's see what happens now. Okay, so this doesn't create the pandas data frame, so we need to use the pandas concatenation, this method here. So we need to concatenate into the data frame. Okay, so not even this, because it doesn't work. So pandas dot concat is the only way to do it. So we rerun that cell because we want that into data frame form, and we'll remove this. So now we rename the columns. So reconstructed dot columns, this gives the names, and that we want seasonal, comma trend, comma residual, comma actual values. So seasonal, trend, residual, and the actual values. So by running that, we get this. Okay. So we are trying to show that the observed value equal the trend values plus seasonal values plus residue. So check actual values equals seasonal plus trend plus residual. So reconstructed data frame, the new column sum underscore check, let it equal to the seasonal column plus the trend column plus the residual column, and we check the first 10 lines, we get this. So sum underscore check is a seasonal plus trend plus residual. And we can see, looking at the fish 10 lines, we can see that the actual values equal the sum check values.